A homogeneous 4 meter wide, 8 meter long rectangular gate weighing 300 kg is held in place by a horizontal flexible cable as shown in figure 5. Water acts against the gate, which is hinged at point A. Friction in the hinge is negligible. Determine the tension in the cable. So this is the cable. So we could think that because we have water here, so there is a force that push the gate, and to prevent its open, so we need to create another force here by connecting this edge into a cable, and it will work like this one. As I said, this cable is actually an external force, so it can work in any direction, depends on the setting. So, and then in this question we have a 300 kilograms. So as you know, if we have a mass, so it will create weight. So weight is also some kind of force, so we need to include the weight in our rotating moment calculation. So we could create a free body diagram like this one. So this is the force of tension T. So and then this is the resultant force. So and then the weight will work downward like this one. So and then because the water is not submerged the gate full, the only partial of them. So we just take the weighted area here, the submerged area, and then we mark the centroid. Then we could calculate the resultant force by using this equation, rho GHCA. So we substitute with 3 sine 30 here to get the vertical height from the centroid here to the free surface here. And then the area is 6 times 4. So we get it is 611.7 kilonewton. We could calculate the YR here by using this one, and then we could get it is 4 meter. And then we need to do the rotating moment calculation. So because we have a hinge at the bottom here, so we could draw like this. So we have a hinge, so we have a plate here, so we have an FR here, so and then we have a tension here, so and then we have a weight downward like this one. So and then to determine the distance, okay, we need to take distance which is perpendicular to the force. So for FR here, we need to take the distance of this one. So the distance A needs to be used to calculate the FR. And for weight here, okay, we need to take the distance of this one, which is distance B. And for this one, okay, we need to take the distance of this one, so which is of distance C. So according to this one, we could take that the distance for T here is 8 and sine theta. So and then the distance for B here is actually 8 over 2 times cos theta. So and then the distance of A here, so we need to deduct with the value of YR. Okay, so and then please bear in mind, if you have a weight here, weight need to be act on the centroid of the object, whether it is submerged in water or not. The centroid to calculate the gravity will always remain the same point. So and then if we calculate, we could get the value of T is equal to 177 kilonewton.